Okay, it's 8:30 today, and welcome to this next HDF clinic. It's all about your questions. I checked the Google document this morning and I didn't see any questions. So should there be other questions during this clinic, just speak up. And right now, the chance is yours. Is there anybody out there that has a question? You can ask it now. Otherwise, as always, I have some material prepared that we can go over, but it's all about questions. So are there any questions? No, not for now. Okay, then let's just see what's been happening. Here is what I would call last week's highlights. First, let's talk about a few announcements. Number one, we just announced that there will be a webinar about one of our projects. It's a joint project up with the Illinois Institute of Technology, IIT, and it's about Hermes, a distributed buffering system for heterogeneous storage hierarchies that is scheduled for Friday, March the 26th at 11 o'clock Central Time, and anybody's welcome to join. Here's the link, and you will find the link in the notes. You can register and then attend. So if you are interested in buffering systems and sort of heterogeneous storage hierarchies, so what we mean by that is, let's say on a modern HPC system, but also other systems, you have things like, okay, you have the RAM, but then you have things like burst buffers or local SSDs, and then all kinds of tiers of storage before you ultimately hit the parallel file system, for example. And then the question is, well, how as a user can we take advantage of that? Another announcement, John Reedy announced that HSDS version 0.63 was released last week, and I linked the forum post here. There are a few news. He fixed some bugs, but there are also some new features, and there is a new Docker image in particular, and that's available from the HDF group Docker Hub account. So if you want to quickly try something, you don't want to install anything or much, just pull that Docker image, and that has everything installed and should get you going. Okay, that's those were all the announcements that I saw. And then I have a few questions, interesting questions that were asked in the forum that we can talk about. But second round, any questions so far? No? Okay, then I will just press on. Number one, there was a question from a user about multi-threaded or writing in a multi-threaded application to a single HDF5 file from C++. And the user was definitely on the right track because he knew, as we explained in our release notes, that in order to eventually use the HDF5 library, you have to, when you build the library, enable thread safety. And so you do that during compilation. Let's say you use auto tools. There is a -- when you run configure, there's a flag called -- enable thread safe. And that will create a version of the library that is thread safe. However, when you enable this thread safe, that disables certain other things. So for example, what we call the high-level library is disabled. Some of the other language bindings and wrappers are disabled because they are not thread safe themselves. So we don't want to create the false impression that now you get a thread safe version of the HDF5 library, that all these other things on the periphery are thread safe as well. They are not. And that was also the comment here. the user seemed to be under the impression that just by having a thread-safe version of the HDF5 library, when you then make API calls into that library from threads, that everything would just be fine. But that is a misconception, in the sense that if your layer, your application layer or your wrapping layer, whatever you might have there, is not thread safe, then of course all kinds of problems can develop. And yeah, and I have the link in here. If you want to follow that discussion, I encourage you to go there. And in the C++ context, yeah, the bindings, the very simplistic bindings that we provide are not thread safe. So that's part of when you do -- enable thread safe, these C++ bindings get disabled. Or if you want to build them, you can. There is another build option where you can say, well, if there are conflicting choices, you are basically saying, I know what I'm doing, I want this, and then you can build them all together. But then again, you have just sort of overwritten a safety feature and you're on your own. So if you think you know what you're doing, then by all means. But yeah, it's not thread safe. And then, but the other bindings out there in the community that are available, they have that safety. And so it's if you really need it and you would like it with C++, then I would encourage you to go out there and see what's in the community, and then fall back or use some of these other fine choices. Any questions, comments on that? No? Okay. The second topic that came up was the, as you probably know, we are converting, beginning with the reference manual, but also other parts of the HDF5 documentation to Doxygen, and that's progressing well. I included links here. Again, it's going to be in the notes. There is a GitHub branch of the a branch in the HDF5 repository of the development branch that has all the Doxygen commentary in this branch, mostly in the public header files. So in header files like H5A public or H5B public and so forth. And there's also a preview available online. I can quickly bring that up here. This is what it looks like if you go to hdf5.io develop / oh, by the way, can you see my web browser here? Hello?
Your web browser is
Yes,
visible.
yes.
Okay, great. Thanks. Yeah, I wasn't sure. I got a little pop-up here that was saying something. Okay, so yeah, so this is, if you go to, the link is in the notes. If you go to hdf5.io develop, you have here sort of a little bit of an overview. External links to external content are marked with this sort of external, with this arrow out of this box. But then, yeah, the reference manual in particular is on the reference manual. So you should see content that looks very familiar to you from Doxygen, but also if you're familiar with the portal, with the documentation portal. However, we have also begun to port or convert some of the technical documentation, for example, technical notes, into this format. So for example, here is a document that describes the API compatibility macros that are available. Here's an old document by John Mainzer about the workings of the metadata cache. Here's something about thread safety, an initial design document. So I make no claim that all these are current and up to date, but it's just to explore how far we can take this. And then here's another document about the virtual file layer. And then here are also some of the specifications. For example, the BNF notation, if you look at the output from H5 dump, how to read this, or down to the file format specification. And here you can actually see different versions of the file format specification, starting from version 1 all the way up to the most current version 3. And so that should all look familiar. And what we would like is really, if you can give us feedback on what you like, what you don't like, what kind of content is missing, what content you would like to see migrated first, because obviously this is a big task in terms of migrating and updating things. But we certainly have our own ideas about what users might think is important, but it's one thing to have an idea about what others might find important and what they really care about. And so by participating in the discussion, you have your voice and your choice. And so, for example, there is also in the existing documentation portal something a little bit like a knowledge base. If that's helpful, by all means, we will bring that over. But so there is your chance to influence this. Okay, any questions about Doxygen or any other questions so far? No? Okay. Another interesting sort of exchange was someone asked about this function called h5i get name, and he found that it was very slow for his file. For this, he found that it was getting slower and slower for larger files, and that is an interesting. It is an interesting function, but also a function that potentially can mislead you if you don't know exactly what this function is doing. So first of all, what does h5i get name do? Well, I've linked the documentation here. If you have an object handle, and this is anything, an identifier that's of type HID_T in the C API. So let's say you have opened a group or you have opened a data set or something like that, then you might ask yourself, well, if this is an object that represents something in an HDF5 file, we know that we can locate objects, as we call them, in HDF5 file through so-called path names. So path names are just basically these strings that are separated by slash characters, so like a path name in a file system. And so in a way, you could view h5i get name as a reverse lookup, where you say, here's an identifier, here's an IP address, show me a URL or a host name for that. So given an ID of HIDT, give me a path under which I could reach this object in the HDF5 file. And when would a function like that be relevant or interesting? Well, it could be, for example, you've written an application, a function, and that is that you pass or that receives such an identifier as an argument. And you might ask, you might know, for example, it might be an application that renders something for a UI, or even has to print just an error message. And of course, if you print an error message, and then since this HIDT in versions, in HDF versions 1.10 and later, is a 64-bit integer, you could print that 64-bit integer, but that would be pretty useless, because these identifiers are really ephemeral. They exist only at runtime, and even if you open the same object twice or multiple times, it will get different identifiers. And so printing that ID would be pretty useless as diagnostic information for a user, let alone to be rendered in some kind of graphical user interface or something like that. So that might be a use case where you say, okay, let me call H5I get name, and basically, given the phone number, so to speak, look up the path name at which I can reach this object. Now, there is something to be said about, this is number one, a pretty costly operation, and this is what this user noticed. And there are two things you can ask. Well, number one, why is it so costly? And what, if anything, does it have to do with the size of a file? And if I answer that last question first, well, first order, it has nothing to do with the size of the file. However, if the file contains a lot of what we call metadata, then there is a certain correlation between the performance of this function H5I get name and the size of the file, and I'll explain why in a moment. But first order, again, unless there is not a lot of metadata, there is really no correlation between the file size and H5I get name. But then why, under what circumstances would this function be slow? Well, it would be slow primarily for the following reason. As people use HDF5 a lot, having this sort of this mental picture in your head that this is a little bit like a hierarchy of directories and files in a file system, there's nothing wrong with thinking about that. However, it can be deceiving if you also think, well, somehow this is how the HDF5 library is implemented, that there is something that looks like a tree, and then that tree is maybe stored somehow in the file. And that is not the case. First of all, there is no tree to begin with. And secondly, this tree is also not stored. And it's not a tree to begin with. How this, what appears as this navigation structure to the user, or what can be rendered to the user as this navigation structure, is really stored in a very primitive form in the HDF5 file. And the form in which it is stored in the HDF5 file is really the counterpart of the directories, so to speak, in a file system, are what we call groups in HDF5. And oftentimes you read formulations like, okay, this data set is contained in this group or is in this group. Well, that is a misleading formulation, because it suggests that it may suggest to some people, well, if something is contained in something else, it cannot be simultaneously contained in another group. So if this data set is in this group, it cannot be at the same time in another group other than by extension. So it may be in the group that contains that group and so forth. But that's not the case. If a group in HDF5 contains anything, it contains these things that we call links. And a link in HDF5 is really a sort of an explicit association that associates a source, in this case the group, with a destination, in some cases this object, for example, a data set or another group, and that's it. So a link is really a collection of links, if anything. So if you say a group contains a link, that's less wrong than to say that a group contains a data set or an object. And now, so all we are given, in other words, is really, okay, we know where this what appears to be a graph begins. We call this thing the root group. So that will contain a collection of links. And then we can traverse these links. And if we discover, we might discover some data sets that are contained in double quotes in the root group, but we might discover also other groups. And then those groups represent collections of links, and then we can traverse those links in turn. And so by extension, sort of forming the transitive closure, if you wish, you can discover all the objects that are reachable through a path in HDF5. But there's still a problem here. Well, first of all, you can see already that is potentially a time-consuming process. If you have a lot of groups and a lot of links and so forth, there is quite a bit to discover. But it's also somewhat problematic because there are very few restrictions on what these links can or cannot do. In fact, you can have a situation where a given object, a given data set is linked to multiple groups. So if you want to think about like in a class hierarchy, some object-oriented languages support multiple inheritance, others don't, but this would be a multiple inheritance example where a given class is a subclass of 2 or more other classes. So that's perfectly fine in HDF5. Another thing that's perfectly fine in HDF5 is that a group can be linked to itself. I'm not trying to pretend here that this is terribly useful, but nothing prevents you in the library from creating cycles, either cycles that are sort of that link a group to itself, but also the group can link to a subgroup, and then that subgroup can link back to the original group. And that's all perfectly fine. So effectively, you are dealing with something that is not a tree. It's not even a graph, because in a graph between 2 given nodes, you can have at most one edge. In HDF5, if you have 2 groups, for example, or a group and a data set, you can have multiple links, albeit with different names, between that group and that other group, or that group and that data set. So it's, I think people use the term multigraph for that. And so taking all these things together, now coming back to H5I get name, if you ask yourself, well, I'm given an object and I would like to find a path that leads to that object. Well, depending on how many possibilities there are, and in the worst case, as I said, in the presence of cycle, there could be infinitely many possibilities to get to that object. This is actually a non-trivial ask, and that's why this function H5I get name is for sufficiently complex multigraph structures and even sufficiently sizable graph structures pretty slow. And and it turns out in this case, if you want to pick up that trail, that forum post, I think the user was in a situation where he wanted to populate, if you have seen visualizations like HDF view, where this graph gets populated, he wanted to create something like that. And then at a given point, he wanted to decide whether 2 objects are the same based on the path leading to them. But that's a misconception, because unless you are dealing with a tree, there is not the path to something. There could be multiple paths. And so path names would be false friends in the sense that they could have different names, but still lead to the same object. And so this is actually not a good way to decide if 2 given objects are the same object. You would use something like that, the address of this object in an HDF5 file, or in HDF5 112, they introduced this concept of a token to work for more general types of storage other than file systems. So for example, object stores and things like that. So you can really distinguish only with some confidence 2 objects, not based on their path name. That unless you are, if you're 100% sure you are dealing with a tree, nothing wrong to use the path name. However, that still will be slower than obtaining the address or the token of something and then just compare two integers. That's much faster than getting link traversal and name lookups involved. So that was an interesting discussion. So H5iGetName has its place again to return some human readable information about an object, but its use is rather limited, and it is kind of a double-edged sword unless you 100% understand what you are looking at when you call H5iGetName. I personally would stay away from it. Definitely not to decide the identity of two objects or something like that. That's kind of abuse or misleading yourself and others. Okay, that was an interesting discussion.
Hey, Gerd.
Yes.
Hi, this is Quincy.
Oh, hi.
Hey, everything you just said was great and correct. I thought I would add just a couple of details if you have a moment.
Sure.
Two or three maybe minor things to add into the iGetName discussion. The library does try, it can lose this, but it tries to cache the path that an ID was opened with. So frequently, it doesn't have to search the full path to find a path to the object. And that, as you say, may be a little misleading for certain circumstances because it looks like it's really fast sometimes, but for whatever reason, whenever it's not managed to keep track of the path correctly, it will have to do that full traversal. So there's a very two ends of the spectrum kind of return, either it's really instantaneous because I already have it in memory, or I got to go look in the file kind of problem. The other one, and you almost touched on it, but maybe you weren't intending to get there. Since HDF5 allows anonymous objects in the file, they're not even connected to the multigraph. They will never get found by iGetName.
Yeah.
So that occasionally will happen. And then you do a full traversal and you still come back with, sorry, man, I can't tell you the name.
Yeah, good point. Yeah. So, I didn't want to go there, but it's great to have it on the recording.
Sure.
Thank you.
Okay. It can also happen for non-anonymous objects that you've unlinked from the graph, but are holding open from an ID. So, yeah, just a couple of minor things. Otherwise, excellent coverage there. That I think that's pretty comprehensive.
Yeah, thanks. Yeah.
Right.
Now it's on record, so people can enjoy it. Sure. I had one more thing, and the time is almost up. This is something our friend Werner Banger came up with. We had a little bit in a different context discussion. He was asking for, well, is it possible in the standard Unix IO API for files, you can open a file in append mode. And he said, well, how do I do that with HDF5? So by opening in an append mode, he means, well, if the file doesn't exist, I want to create it and then have it available to me in read-write mode. Or if it does exist, I don't want to override it. However, I want to open it in read-write mode. And then, of course, there are some corner cases. For example, what happens if the file exists, but it's not an HDF5 file? And the solution he came up with looks like this, and I think it's correct. And forget about the swimmer, but the swimmer is important in his use case. What you do is basically you call H5F create with exclusive access to the file and swimmer write or read write. And if the file exists, then H5F will create, but then you will recover from that with H5F open file name. And if the file is not an HDF5 file, then that will fail as well. So you are covered there. And the other way around, if the file exists, then the exclusive access to the file will fail. and you will execute the fopen, and then even if that's not an HDF5 file, then the fopen will fail as well. But it looks like the combination of these two seems to achieve that semantic kind of an append, open a file in HDF5 in append mode in double quotes. Okay, it looks like time is up. Again, the notes will be published online, and thank you everybody for coming. Thanks Quincy for a great comment, and we'll see you next week. Thank you. Bye.